To obtain chocolate products with a good gloss, the chocolate must be pre-treated after melting. The chocolate has to be tempered or pre-crystallized. If you don't do this, you will get a grey, dull, sometimes even rough-looking surface. How come? Chocolate consists of a high percentage of cocoa butter. This is a fat with a very specific crystalline structure. If melted cocoa butter is allowed to set again, a crystallization process begins during which very coarse crystals form. But only a fine crystal lattice of the good type of stable crystals will impart to the chocolate the desired properties of hardness, a good gloss finish, and contraction. 6 different crystalline forms are possible, but only one of them is desirable to give the chocolate these properties of hardness, a good gloss finish, and contraction, and that is the beta form. How do you achieve the beta form? There are 2 possible methods. You either create the beta form, or you inoculate the chocolate by adding existing beta crystals. Since the presence of the beta form cannot be seen in melted chocolate with the naked eye, and there is as yet no instrument that can indicate the beta form in a straightforward manner, we will show the first method with cocoa butter. Melted cocoa butter is somewhat transparent. As soon as crystallization occurs, it becomes matte and opaque. Pour a little of the cocoa butter onto a marble surface. Work this cocoa butter while it cools. You will then produce a mass of crystals within a short time, both the good, stable type and the unwanted, unstable ones. The crystallization process is therefore not uniform. By quickly mixing this cooled portion with the remaining warm portion, the unstable forms melt again, leaving only the stable form. The cocoa butter is now matte and opaque. It is pre-crystallized, or, to use the specialist term, it is tempered. If you repeat this method with chocolate, you are not able to check whether the chocolate is transparent or not. Experience shows that chocolate must be observed during pre-crystallization. As soon as you see that the portion being worked on the marble is beginning to thicken slightly, you must add this to the portion that is still warm. By quickly blending the warm and cold portions, the chocolate is pre-crystallized. In practice, it is usual to pour about 2/3 of the melted chocolate onto the cold table, provided that the chocolate has a temperature of 40 to 45 degrees Celsius or 104 to 113 degrees Fahrenheit. If the chocolate is warmer, pour out a little more. This method is used by makers of handmade chocolates. In addition to the method just discussed, in which you produce stable beta crystals by cooling and reheating, there is a second pre-crystallization system, namely inoculation of the melted mass by adding stable crystals. Let's take a look at the principle behind this method. The cocoa butter in this beaker has a temperature of 40 to 45 degrees Celsius, or 104 to 113 degrees Fahrenheit. There are therefore no crystalline forms present. What happens now if we add stable beta crystals? If we only add a small quantity of crystals, they will melt in the warm mass. The temperature of the melted mass will fall, however. If we add enough stable crystals, that is, around 25% of the total quantity of cocoa butter, not all the crystals will melt after intensive blending, and at the processing temperature of 31 to 32 degrees Celsius, or 88 to 90 degrees Fahrenheit, there will be enough stable crystals left to initiate the crystallization. Callebaut offers these stable crystals in its product range in the form of large chocolate drops, or callets. These callets are of uniform shape and available in many flavors. They offer the chocolate maker an ideal aid for tempering the chocolate mass, or couverture. Add 20 to 25% callets to the melted couverture. Blend the mixture quickly, which then provides a mass which is ready for further processing. Those using a blending machine can also apply this method for pre-crystallization. On the evening prior to production, fill the machine with blocks. The following morning, switch the machine on, lower the thermostat, and add the callets. As soon as the processing temperature is reached, the mass is inoculated or tempered, and you can start working. This is an extremely fast method. In addition to time and temperature, movement has a marked effect on the multiplication of the stable crystals already present in the couverture. You can yourself find this multiplication process going on when the couverture begins to thicken. This phenomenon, also known as overcrystallization, causes problems, a higher viscosity which results in a greater layer thickness. The air bubbles present disappear less easily. Graying and a loss of contraction are frequent consequences of overcrystallization. So, isn't it possible to avoid this overcrystallization? Yes, there are 3 simple ways which all offer the same result. As soon as you notice that the mass is beginning to thicken, increase the temperature by 0.5 to 1 degree Celsius or 0.9 to 1.8 degrees Fahrenheit. Repeat this until the chocolate has the same viscosity as when you started work. Take care, because above 35 degrees Celsius or 95 degrees Fahrenheit, the stable crystals will melt after a time, meaning that the chocolate must be retempered. For milk and white chocolate, these temperatures are a little lower because of the milk fat present. If you use a lot of chocolate and you wish to maintain a constant level in the machine, it is better to add regularly a quantity of untempered warm chocolate, 45 degrees Celsius or 113 degrees Fahrenheit, to the overcrystallized mass. The surplus crystals are melted by the warm chocolate. This ensures that the quantity of stable crystals remains constant. If the chocolate is excessively overcrystallized, however, the use of a hot air gun is recommended. The hot air will very quickly bring the excess quantity of stable crystals back to the required level, enabling you to continue working without problems. Take care not to burn the chocolate with the very high temperature. Before we leave the subject of pre-crystallization, let's take a look at working with a microwave oven. A microwave oven can be very useful for anyone wanting to melt or pre-crystallize a small quantity of couverture very rapidly. It is actually possible, starting from hard chocolate, to obtain a pre-crystallized mass within a very short period of time. It is very important to heat the chocolate in short stages and stir it regularly. Once the chocolate begins to melt, it's important that sufficient crystals remain so that the mass can be inoculated. If the chocolate is left for too long and at too high a power in the microwave, there is a real danger that the mass will burn. Once the chocolate is pre-crystallized, there is still an essential additional stage before it can be said to be a perfect finished product with a good gloss, hardness and contraction. This important stage is the cooling process. Cooling is necessary to dissipate the heat of crystallization and give the crystals the chance to create a stable crystal lattice. There are 2 types of cooling, by radiation or by convection. Radiation cooling is used for cooling coated or enrobed products. Ventilation in the cooling tunnel after the enrobing machine should thus be avoided as far as possible if you wish to ensure a good gloss. Convection cooling is mainly used for cooling molded products. During cooling with this process, ventilation is used to dissipate the heat more quickly. There are 2 reasons for this. Firstly, the layer of chocolate is usually thicker, and secondly, the molds themselves have an insulating effect, and make heat dissipation more difficult. What do we mean by good cooling? It's important for the chocolate to be cooled properly, that is, not too slowly, but also not too quickly or with a shock. If cooling is too slow, the heat of crystallization is not dissipated quickly enough. As a result, the stable crystals which were formed during tempering cannot build up a fine crystal lattice and instead crystallize out very coarsely.